Yeah, this is my agenda. I'd like to introduce the destination where we wanted to get with our project. Then from A, the source data, to B, the destination schema. And we had some quality assurance in our project and encountered some obstacles, but found out that FME is a very good driving assistance for data obstacles. At the end, I would like to introduce you to Mr. Müller and show a bit of the road ahead. So the client was the Stadtwerke of Münster. It's a contractor for electricity, heat and water. And it's a local public transport agency for the city of Münster, where Conterra comes from, not only for Münster, for the Münster region. And they have 150,000 passengers per day and 100,000 of arrivals and departures of buses and yeah, every day. They have a 400-kilometer bus network with 600 stations, 18 bus routes and 6 night bus routes, and 16 taxi bus routes that are available on demand. So at the beginning of our project, this was what's like the customer information about timetables. There were printed timetables at the bus stations. There were ticket and timetable information available on the website in form of a PDF. And they have a Fahrgastinformationssystem, FIS, which means Customer Information System for customers. You can see it on the red side of the slide. It's departure times and bus stops at the bus stations. And they have apps for Android and iOS for buying tickets, for consulting for departure and arrival times of buses. But these were apps that you can download from the website of the Stadtwerke of Münster. So foreign visitors just visiting Münster for 1 week, or I don't know, just occasionally, they might not get to this information because they won't get to the website of the contractor to download the app on their mobile device, because you can't download an app for every city that you're visiting. Like you might not have the app for Vancouver. I don't know. I talked to Lassi Tani yesterday, and he told me that without a Google Transit and Google Maps, he might get lost in Vancouver. So the destination was to just promote multimodal routing in the city of Münster. That's to say, bus per feet, bicycle, or by car. And when we started the project in 2012, it wasn't that common in Germany. There were no public transport agency live with their data, timetable data, in Google Maps. So our goal was to make Stadtwerke Münster the first public transport agency on Google Transit in Germany. And therefore, we had to transform and transfer the timetable information to Google Transit. And that's a typical FME challenge, getting data from schema format A to schema format B. So from A, the source data, there were multiple applications, databases, and files to store the timetable information of Stadtwerke Münster. They had export formats on national VDV. It's a national transport club or association of transport agencies in Germany. They're really huge standards formats, and but they were heterogeneous. That's to say, they had some ASCII CSV files standards with and without header, and they had an XML standard. Don might not like this, but we used the CSV standard, not the XML standard. It was called Dino. Yes, to transform the data. And B is the General Transit Feed Specification, formerly known as the Google Transit Feed Specification. This is an open standard, and it's a zip archive with CSV files storing the information of the routes, the agency, the calendar, the trips, and the stopping times, for example. It is extended by GTFS real-time extension, which is a binary format. And you can, there was a specification discussion board in the internet where you can discuss this new open standard. As I mentioned, we did some quality assurance during our way of the data mapping. We did some QA with FME when we first reviewed the data. And of course, during the process, we encountered more and more obstacles and errors or missing data in the client's data. And these were errors that the client wasn't aware of before we started this project. For example, the completeness of data. There were route names missing, or destination descriptions were missing or wrong. For example, description would be waterfront for the waterfront line. There were route geometry was missing completely. There were some bus stop descriptions needed. For example, there are some bus stops where you can only enter into the bus, but you can't get off. It's entry only, entrance only. And there were some taxi bus. You have to know that this is on demand, so it's not on a everyday or on a regular schedule. We used some Google tools within FME. So Google is providing some tools to to quality assure your data. You use Python shutdown scripts for integrating the feed validator and create the HTML report with the errors in the data. We created a batch file with a shortcut to the schedule viewer so that at the end of every FME process, the schedule viewer shows up automatically and shows the data in the offline schedule viewer of Google Transit. So these are the Google tools. I know you can see it. And this is a HTML report coming up out of the Google Feed Validator. And he's found 130 warnings. For example, this is 129 errors on too fast traveling. So if the times, bus stops at every station is too close, and the distance, I don't know, it's 10 kilometers. There were some examples where the bus has to go 200 kilometers per hour to reach from getting from one point to the other. So we had to control this or review this and do a correction in the timetable so that he don't have to fly the bus. This is a Google Schedule Viewer. It's a graphical interface. You can use offline to review your data. So you can see, whether the bus stations are connected in the right order. And as well, on the bottom you can see, the timeline, how the bus is driving from one station to the next. One obstacle that we found were almost non-spatial data. The timetable applications of the client were non-spatial, so he stored some information like coordinates of the bus stations, but he wasn't aware of whether the coordinates were correct or not. So the client has 600 bus stations with 1,200 bus stops, but 50 bus stations without any location in the database, or 200 located on the center line of the street, and 300 located completely wrong. So the solution was a new theory with GISPad, which is a serving application from Contera, and then replaced and controlled these new bus stations locations within ArcMap with the help of some auto photos. This is a stop to close is one error that was thrown by the feed validator of Google. That's when a bus stop is redundant in a database. It's to say it's too close to the other bus stops, or one bus stop had different identifiers on the different routes. So there were taxi bus, there were night bus, and the normal bus, standard bus, all driving to the same bus stop, but with another identifier. So we had to harmonize these identifiers. And sometimes it is exactly the same coordinate, sometimes a discrepancy in a few centimeters. So of course the FME solution was to use the duplicate remover and the feature merger to remove those duplicates from the database on coordinates rounded 2 meters, so that we can just identify the redundant bus stubs. Then we had to do a coordinate transformation from the coordinate system of the source data of the Dino export format in the German zone 3 of DHDN to the GTFS destination coordinate system. And there were very insufficient results with a standard high precision transformation, beta 2070 NTV2, and the 7-parameter transformation. We had an offset of 5 meters. As you can see in this, oh, you can't see it very good. There were 5 meters offset between the bus station coming from the source data set and the bus station, how it should be in the Google Transit or in the Google Maps application. So nobody would miss a bus on 5 meters, but yeah, we had to do Coronet transformation. So we implemented the Google transformation, or the way Google transforms this data, which is a bit unprecisely, with a transformation parameter in the mycords sysdef.fme, which is a configuration file in FME, just to solve this problem. Another obstacle was the representation of stop times. In the source database, there were more or less relative stopping times. Let's say the bus departures at one time from station X, and then the next stops is in 60 seconds or 1 minute, and the next in 2 minutes. And GTFS requires the absolute or the absolute exactly times in the data in the timetable. As I say, it's just 23, 24, 26 instead of 23 plus 1 minute plus 2 minutes. So we built a routine in our transformation process using the variable setter and the variable retriever to calculate the absolute time schedules of every bus stop on every route. Yeah, it was better to use the variable setter and the variable retriever because it was less runtime than using the feature merger. Another obstacle was on-demand taxi buses. The taxi bus is on demand, and so there are several bus stops that have the same stopping time. But GTFS doesn't allow identical departure times on consecutive stops. So we just removed the redundant stopping times with the sorter and the variable setter and set them all to one stopping time, but removed the redundant from the timetable. And then we go to the Google Transit Partner Portal, where the agency can just register, and they had to publish the feed on their own. And there are 2 options to upload these files to Transit to the Partner Portal. You can upload via CSV files directly, or you can provide a secured URL with a feed of the data. So the transport agency publishing the data is still the owner of the data. When they remove the feed, no timetable would be published or shown in Google Transit. And then Google does an individual review by at the first upload of the data. And this took us quite long. Oh, this is a Google Transit Partner Portal, by the way. There's a visual route control by the user where you can see whether the route is fine or correct would be shown in Google Transit. and you can see all the trips here in an overview. And you can, you can create test routes, test trips to test whether the results that would come out of Google Transit are correct or not. So we had received the final review and approval by Google in July 2012, and then they published the German railway timetables in August 2012. But the Stadtwerke of Münster was the first local public transit agency in Germany to be published on Google Transit, together with the city of Munich that haven't used FME for this process, but they told us that they needed 300 hours to do the work.
2 years.
2 years? Okay. Okay, and I don't know, Tino, how long did you? 2 weeks? Longer? 3 months, okay. So
It had to do those manual geolocating of 50 stops, which took most of the time.
okay, yeah. So FME does a good job on this. And afterwards we showed the city of Munich how we did it with FME, and they would, they were crying a bit, So destination reach in our project, City of Münster was, together with City of Munich, the first local agency to be published on Google Maps. And this is Mr. Müller, and he is visiting Münster for the first time. I am visiting Vancouver for the first time this week, and he likes to go from the main station of Münster, which is here, to the castle of Münster, which is very beautiful and is here. He doesn't know how to do that. Oh. So this is Mr. Müller, and he likes to go, as I said, from the main station. You see in the Münster for the first time, he likes to go from the main station to the castle of Münster, and he doesn't know how to do that. Okay. Maybe my internet connection is lost. Okay, but he does the Google Transit app on a smartphone, and he just enters the information into Google Transit, and the whole trip is timetables are published in Google Transit, and now he's happy to go from A to B with the help of FME and the timetables published in Google Maps. So if you like to have Mr. Müller, a very happy Mr. Müller in your town, you can publish your data in Google Transit with the help of FME. If you want, you can contact FME at Conterra to help you, to assist you. So what we want to do now as a second step in our project is to implement the real route geometries in Google Transit. So now it's going from A to B, no matter what the streets are saying. And we like to implement the real geometries of this, where the bus is driving. We want to implement the GTFS real time. That's to say, the real-time departure and arrival of the buses in Münster. We have the access to the real-time API of the city of Münster, of the buses, since 2 months, and we are working on that. And we like to inform the customers about the delays of autobuses, possible delays, shifted or interactive stops, because of constructions, and the real-time vehicle locations, where you can, so that you can see when the bus is coming and where it is at the moment, so you won't never ever miss a bus again. So for more information, you can contact FME Contera, or contact me or follow me on Twitter. Yeah, and thank you very much for your attention.
So we've got a couple minutes for questions here, if there's any. Got one there? I'm gonna pass the mic down from here.
Oh, yeah.
Okay.
What would you have to do if you were having a festival at the castle and therefore had a new schedule for one night?
Then you can just upload a new feed, and you can say, okay, the feed is valid from this day or only for this weekend. So you can change it you can publish more than one feed at the same time in the partner portal.
The feed has a timestamp.
Yeah.
I see you use GeoTools for validation. What does this tool offer that FME can't offer? For the data validation with all the errors we saw?
These tools are the rules implemented that GTFS is requiring for the data, for the timetables. So it has an optical review, an optical graphical interface for reviewing the data, and as well it's showing errors like stops to close. Okay, you can very easily sort that out with FME as well, but the too fast traveling as well. Yeah, right. But these are the routines that are running behind the Google Transit portal, and yeah, you can use it directly to validate your data. So you can pass every FME rule with the data, but maybe miss some of the errors that are integrated in the feed validator. So that's why we implemented it, to avoid conflicts with the partner portal of Google Transit.
What's GIS pad, and did you have to go into the field to validate any of the bus stops?
Sorry?
What's GIS pad?
There was a GIS part to collect some
You
data.
used an application called GIS pad.
Okay.
Your application is on mobile, don't you? It's a small application to collect
okay.
data in the field.
Yeah, so you did go into the field to.
Yeah, we
Some of the
sent
bus
someone to the field. Oh, sorry.
Sorry, my accent.
You have any more? One over there.
I can deal with that.
Okay.
So, is there a missing data conversion that you needed for your loan distortion 1 to WS84? Because you had to define a new one? Ethnic wordsys file that you edited, it was NTB2 and 7 parameter that did not work for you?
Yes, we had to implement a new one because I know the data in Google Transit, they aren't exactly, the coordinates aren't that exact like the transformation that FME does. So we just did a more or less, less precise transformation, let's say. Tino?
So Google just buys all the training data from the local agencies in Germany, and Google uses a very generic 3-parameter transformation to get all of this data into Google Maps. So if you do a high precision transformation of local coordinates and then overlay them on Google Maps, you get this offset.
You needed to preserve inaccuracy.
If you want.
We got anyone else here? Okay, great. Well, thank you very much, Benjamin.
Thanks a lot.
Yeah.
If you have time today or tomorrow, you can access at this web page to download our beta version of the Mission Control for FME Server app. so where you can just monitor your server processes while you're at this conference, so that you're getting sure that none of your processes fails. So, yeah, if you want. Thanks.